Let's talk about frame of reference. Frame of reference is a real or an imaginary object with respect to which motion is described. When we say something is stationary or something is moving with this velocity and this acceleration, who is the entity saying that the motion is taking place? That entity is frame of reference. In physics problem, we will often describe frame of reference with help of xy axis or xy and z axis. Here is a dangerous concept. If you do not define frame of reference, we simply cannot talk about motion. However, in daily life, we often say that this car is stationary, that bike is moving, that person is accelerating. We don't really talk about frame of reference in these cases. See, we live on Earth. In our daily life, we often use Earth as the default frame. So when we say that a car is stationary, what we really mean is, with respect to Earth, that car is stationary. When we say that a bike is moving, what we mean is, with respect to Earth, that bike is moving. Default frame is okay. However, if we don't really have a default frame, then we cannot talk about who is moving and who is stationary. What does that mean? Imagine a place far away from Earth, Sun, solar system, Milky Way, everywhere, somewhere in deep space. There are two objects which are moving past each other. So which one is stationary and which one is moving? It depends. If you pick this object as the frame, this object is moving. If you pick this object as the frame, this object is moving. There is no fundamental frame and fundamental motion. It is up to you which of the object you want to pick up as the frame. Inertial frame is a frame which is having zero acceleration. It may be stationary or it may be moving with a constant velocity. It is important to know about inertial frame before studying laws of motion, because Newton's first law and second law are only valid from an inertial frame. I am assuming that you have already studied laws of motion briefly in class 8, 9th or 10th. Only in that case, the next I will be able to explain why inertial frame is so important for Newton's laws. Look at this pen stand. It is stationary. There is no force on it. It is not having any acceleration. Everyone is happy. But there is an observer who is moving like that with acceleration. That observer is going to say that from my frame, this pen stand is accelerating in this direction. We are going to tell that observer that this pen stand is not accelerating. In reality, you are the one who is accelerating. That observer is going to say, sure, but from my frame, this pen stand does not have any force. Agreed? But this pen stand is having an acceleration. And that observer is correct. This pen stand is actually having an acceleration without any force from his frame. Point is, Newton's laws are not valid from non-inertial frame. That observer is accelerating. As a result, it is a non-inertial frame. Before we apply Newton's law, we need to make sure that the frame itself is not having an acceleration. Laws of motion are only valid from inertial frame. Most of the time, we will be applying laws of motion from Earth's frame. That leads to a natural question. Is Earth an inertial frame? I have a bad news. Earth is rotating around its own axis. Earth is also revolving around Sun. Both of these are circular motion. Later on we will study that in circular motion an acceleration is always involved. That means Earth is not an inertial frame and laws of motion cannot be applied from Earth's frame. I have a good news. Acceleration of Earth is not very high. We can apply laws of motion from Earth's frame on an approximate basis. And this approximation is quite good. All these large buildings, all of them assume Earth to be an inertial frame, and we are able to build those buildings very well. So this approximation is quite good, and we can proceed with applying laws of motion from Earth's frame. However, if someone asks us directly Whether laws of motion is valid from Earth frame, then we will have to admit that Earth is not an inertial frame and laws of motion cannot be applied directly from Earth's frame. Now we can talk about Newton's first law. Newton's first law states that when observed from an inertial frame, an object maintains its state of rest or motion until and unless some external unbalanced force acts on it. What does it say? It says that if an object is at rest, it will remain at rest unless you are applying some force at it. If an object is moving with constant velocity, it will continue to move with constant velocity unless you apply some force on it. This is same as the law you have studied in junior classes. There was one difference. The frame, the observer, has to be inertial. If the observer or the frame is accelerating, then Newton's first law may not be valid from that frame. There is one more thing. Who gave Newton's first law? Well, obviously Newton. No, the Newton's first law was given by Galileo. It's quite interesting actually, but don't worry. Newton's second law and Newton's third law were given by Newton himself. Newton's first law is also called law of inertia. What is inertia? Inertia is tendency of an object to maintain its state. When you get up in the morning, you may not feel like coming out of bed. You may feel that you should lie there forever. This is inertia. In Newton's first law, there are three types of inertia. The first is inertia of rest. An object at rest always wants to remain at rest. The second is inertia of motion. A moving object wants to continue to move. The third is inertia of direction. If a particle is moving in a particular direction, that it wants to continue to move in that direction only. Inertias can be overcome by force. Let us look at one example of each of the inertia while I am riding in a bus. Bus is at rest. Suddenly it begins to accelerate forward. Lower part of my body is able to accelerate as it is connected to the seat. The upper part of my body is relatively free. It wants to remain at rest. It appears that upper part of my body is falling backward with respect to bus, while the reality is upper part of my body wants to remain stationary while lower part is ready to accelerate forward. This is example of inertia of rest. Later on, the bus was moving and suddenly it brakes. Lower part of my body is able to stop. Upper part of my body wants to continue to move forward because of inertia of motion. As a result, it appears that upper part of my body is falling forward with respect to the bus. Let us look at inertia of direction. The bus is turning. The lower part of my body is able to turn, but upper part of my body wants to continue to move in forward direction. As a result, it appears that with respect to the bus, upper part of my body is falling outwards. This is example of inertia of direction.